Welcome back, students. This is the Q&A session 9 from the playlist of motion in a plane. The topic is projectile motion, and today I have taken one question which was asked in the CBSE All India Pre-Medical Test in the year 2014. And this question is based on finding the value of acceleration due to gravity on another planet. The question here is: a projectile is fired from the earth with a speed of 5 meters per second, making an angle theta with the horizontal. Another projectile is fired from another planet with a speed of 3 meters per second at the same angle and following the same trajectory. The value of acceleration due to gravity on earth is taken as 10 meters per second square. So the value of acceleration due to gravity on the other planet is. So we have been given 4 options here and we have to find the correct one. So this question is very easy, and this question is basically based on the equation which defines the projectile, which defines the trajectory of a projectile. So the equation which defines the trajectory of a this projectile is given by y is equal to x tan theta minus gh square divided by 2u square cos square theta. Now here y is what? Y is the vertical distance covered by the projectile at any moment of time. X is the horizontal distance covered by the projectile at any moment of time. Theta is the angle of projection of this projectile, and g is the acceleration due to gravity. So since the trajectory of both these two projectiles are the same, therefore y, x and theta is also the same in this equation. So these y, x and theta are the same, and if the trajectory of both these two projectiles are the same, then g upon 2u square, this value should also be the same on both the planets, that is on the earth and this another planet. So if the value of the g on the earth is taken as ge, now here the projectile is fired from the earth with a speed of 5 meters per second. So I am taking this speed as ue, and let us consider the acceleration due to gravity on the other planet as gp, and the speed of the projectile with which it is fired from the other planet is given as will be taken here as up. So if the trajectory of both these two projectiles are the same, then this value, that is ge upon 2u, this ge upon 2u 2ue square should be equal to gp upon 2up whole square, because g upon 2u square has to be the same for both the trajectory, for both the trajectory. ठीक है. So ये value अगर आपका, since it has to be the same for both the trajectories, so therefore I will be using this equation in order to find the value of the acceleration due to gravity on the other planet. So ge is equal to 10. Now ue square will be equal to 25, that is 5 square. So this is 25 into 2 will be equal to 50. gp is something which we have to find, and up is the speed with which this projectile on the other planet is fired. So this is equal to 9, that is 2 into 9, which is equal to 18. So gp will be equal to 180 divided by 50. This will be equal to 18 by 5. Or we can say that gp will be equal to 3.6 meter per second square. So the acceleration due to gravity on the other planet will be equal to 3.6 meter per second square, and the correct option is A. Now here the only thing which you have to the only formula which you have to use here is the equation which defines the trajectory of a projectile. So by using that equation, we were able to find this value, And thank you very much for joining this session. In the next session, I will be coming up with a different type of a question based on the projectile motion. So till then, have a nice day. Bye.